a function. So this would be like if you took a function, something that maybe is like this, and you kind of go, okay, what if I found every single y value on this function and averaged them? I mean, on some level, what you're doing is you're just taking this function, maybe this is the average, and you're just stretching this out. You're stretching it out into a line because that's the average value. So pretend that's the average, that's the middle of the whole thing, and what we would end up doing is just stretching it out and saying, okay, well, now we have an average. It would be like if you were taking every single dot on this, adding them all up. I've only drawn a finite number of dots, but if we took every dot from A to B and we added them all up and divided by the range that we have from from A to B, we would get the average value. In calculus, what we do with that is the average value of a function is found by doing the following. You do 1 over b minus a times the integral from a to b of f of x dx. Or you could think of it that way. That's one way you could set it up. Another way to think about it is going from the integral from a to b of f of x dx. Remember that adds up all the values divided by the range of values that you have from b to a. That would be the same thing. That's how you find the average value of a function. Now that's different than finding the average rate of change of the function. There's some similarities, but the average rate of change of a function, if you remember back from when we were doing that, is that's the same thing as the slope. So that's f of b minus f of a divided by b minus a. You can see that they're really pretty similar things, especially because you can kind of see the f of b minus f of a is on some level a fundamental theorem kind of thing where you integrate and you do the top bound minus the lower bound. But the key is this one has the word rate in it, and this one has the word value, or really rate of change. So that's how you can signify which one am I going to use. Super important to get that to recognize what's what. So I'm just going to do some examples and show you how this is used. So let's take this first one. Here's an example of, you got these regions A, B, and C, A, B, C, and D, and region A has an area of 14, region B has an area of 14. That's really going to be negative 14 because it's below the x-axis, so I'm even going to write it as negative 14. Region C has an area of 6, and region D has an area of 8, so I'm going to make it negative 8 because we're below the x-axis there. So what is the average value of the function f on the interval negative 3 to 4? So here's what we're being asked to do. Notice it says average value. So the average value would be 1 over 4 minus negative 3 times the integral from negative 3 to 4 of f of x dx. Here's the graph of f. So we got 1 over 7. And then remember that that's the sum of those. We did those a couple days ago. So we'd have 14 minus 14 plus 6 minus 8. So together we get negative 2 over 7. That's the average y value. That's the average y value on that interval. And it should make some sense. When you look at it, it's a little bit below the x-axis, a little bit more than it is above the x-axis. So that's why the average value is a little bit less than 0. That should make some sense to you. If you stretch that curve out from oh, I didn't even do that right? So hopefully you guys caught that. So I'm going to change that because I went from -7, but I'm only supposed to go from -3. So the only thing, so what I'm going to do is I'm going to change my computations. Hopefully you guys caught that. But what I have is I am only working with -3, this region, and this region. That's the only regions I'm working with. So if I stretch that out, it's still going to be negative, right? Because I still have -14 plus 6, so -8, right? Over 7, -8/7, right? -8 over 7. So a little bit less, -1 and 1 1/7. That should make sense based on where that thing is. If we stretch that curve out, averaged all the y values, we'd get -8/7. So hopefully that makes sense. Sorry for making that mistake. I wasn't paying attention to the interval. Really good point to make sure you pay attention to the interval. All right, so let's take something like this. What's the average value of f on this interval? Written in simplest form. So we know that we have the average value is what we're looking for. So if we do 1 over b minus a, the integral from a to b of f dx. So we clearly have 1/2. That's just a constant. It can stay out in front. If we integrate this, we get 2x cubed over 3 minus 5x squared over 2, evaluating it from -1 to 1. And now we're going to do the fundamental theorem. If we do the fundamental theorem, we got this 1/2. We plug in the top bound, so 1. So we'd have 2/3 minus 5/2 minus, and then if we do plug in -1, we have -2/3 minus 5/2. And then we're just going to do some arithmetic on that. So we got 1/2. This would be 2/3 minus 5/2 plus 2/3 plus 5/2 if I distribute that negative through here and here. And so we got 1/2, and we got 2/3 plus 2/3. So together we have 1/2 times 4/3, which in the end, Delta Math is going to want you to write that as 4/6 or 2/3. And that would be our answer. All right? So that's just the arithmetic, but the setup is that average value of that function. So let's look at something like this. What's the average value of this one over this interval? Now we got a function that's defined as the sine. This one's going to take a little bit more when we do this one. I might not finish it, but I'll get it started for you. So when we do the average value on this one, we're going to do 1 over b minus a times the integral from a to b, and I know I did not leave enough room for this, of the sine of pi halves x dx. We're going to have to use substitution on this. So hopefully that you kind of see where this is going. At the very least, we got this equation that we can work with. This particular thing is if you do 10/3 minus 4/3, that's a lot like 6/3, which is 2. So this is just 1/2. And if we keep on going with this, we got 4/3 to 10/3. And I'm actually going to do a little bit more work on this. I'm actually going to say, okay, well, u is going to be pi halves x. So du is equal to pi halves dx. We don't have a pi halves, so we're going to do 2 over pi du is equal to dx. So if we go through this, plug in 4/3, remember this is x, the lower bound is going to be based on u, and so we end up with the lower bound being 4 pi over 6, and the upper bound being 10 pi over 6. Now, if you haven't done the u substitution stuff, that's going to be really challenging what we did there. But now this is the sine of u times 2 over pi du. One of the things that you can look at is look at the 1/2 and the 2 over pi. That means really the constant that we have on this is 1 over pi, because these 2's up here are going to go away. The integral that we have is we have this integral 2 pi over 3, 2 pi over 3, and 5 pi over 3. And we got the sine of u du. Now, I will put a video on, another video on a trigonometry review, but for the purposes of this, I'm going to go pretty quickly on this and do the calculations, and you should watch the trigonometry review to come back to this if you don't understand how I get the numbers. But the integral of sine is negative cosine, right? So hopefully you know that. That's negative cosine. U evaluated from 2 pi over 3 to 5 pi over 3. So if I continue this down here, I have 1 over pi is the outside. So I got negative cosine 5 pi over 3 minus negative cosine 2 pi over 3. Now, cosine of 5 pi over 3 is going to be positive 1/2. 1 over pi. So this is negative 1/2, because that's 5 pi over 3 is positive 1/2, plus the, and that's just because we can get rid of those, and then the integral, or the value of cosine 2 pi over 3 is negative 1/2. And again, go back and watch the video that I will put up there about trigonometry to review that. And in the end, we got negative 1/2 minus a negative 1/2. That's negative 1. So I think the answer is negative 1 over pi. I know that that one was a little bit tough, but that's the answer to that one. Piecewise functions. If you have a piecewise function, you can do the same kind of thing with this, but notice that we're going to have to split this integral up. The integral from negative 1 to 3 of f of x dx, in this case, we really need to do the integral from negative 1 to 0 of 4x minus 6 dx, plus the integral from 0 to 3 of 6 dx, because that's where we make this split at 0. So that's why I've split this into 2 integrals. Now we can integrate these and kind of continue on with this process, knowing that we have the integral of 4x minus 6 is 4x squared over 2 minus 6x evaluated from negative 1 to 0, plus, I'm going to put parentheses around this because I'm adding this whole thing. Actually, I don't even know that I need to, but so, but I have 6x evaluated from 0 to 3. Now, if I continue this process and I plug in 0 and I plug in negative 1, if I notice from this first one, if I plug in 0, it all goes away. So I have 4 over 2 minus 6 times negative 1 plus 6 times 3. because when I plug in 0 again, that goes away. If I continue this, I got 2 plus 6 plus 18. So together I have 26, and that's my answer. But I can split an integral up if I have a piecewise function and just make sure that I surround it by the bounds. Now we could do that same thing with the average value, and it wouldn't change it at all. I'm going to start this one. I'm not going to finish this one, but if I'm going to use the interval -2 to 3 and it asks me for the average value, notice that I make this switch at 2. So the average value would be 1 over b minus a, integral from a to b of f of x dx. But notice that that means I have 1 over 5, and then I do the integral from -2 to 2 of -3x squared minus 7 dx, plus the integral from 2 to 3 of 3x squared dx. And if I were to continue that problem, I could get it, but again, I used the average value because that's what it asked me for on there. I'm not going to finish that one. I think you guys could go through the process of finishing that using the fundamental theorem and all the things that are involved with that. I'll do one more step on it, but I'm not going to do the arithmetic on it. So I got 1/5, and then I got -3x cubed over 3 minus 7x evaluated from -2 to 2 plus 3x cubed over 3 evaluated from 2 to 3. And then I could go through and calculate that. I've run out of room, but you get the idea on that one, hopefully. Now this last one is a little bit trickier. The first ones were a little straightforward. This one's a little bit more what I would call theoretical. And it says, notice functions f and g are continuous and differentiable. It just identifies that we don't have any goofy things happening. With f of x equaling g prime of x. Really important thing to note right away is that if f of x equals g prime of x, then the integral of f of x is equal to g of x, right? I mean, if the derivative of g is f, then the integral of f is g, if you think about where we are in the table, or where we are in the chart, or where we are on those steps. Selected values of f and g are shown below. If the average value of f of x on the interval 1 to 13 equals -1, what is the value of g of 1? So you might go, well, how in the world would I find that? Well, let's look at this. Average value on this interval is equal to 1. What that means is the integral 1 over 13 minus 1 from 1 to 13 of f of x dx is equal to -1. Well, look what we did. We kind of had this, this integral of f, which we know is g. So if we kind of keep on working with this, and we kind of go, okay, well, let's keep on working this. We got 1 over 12. And if we integrate f, we should get g, evaluated from 1 to 13. And we know that equals -1. So if we kind of keep this going, we got 1 over 12 times g of 13 minus g of 1, using the fundamental theorem, equals -1. So notice g of 13 is right there. So we got 1/12 times -7 minus g of 1. We don't have g of 1, but that's what we're supposed to find, equals -1. This is just an algebra problem at this point, right? I mean, this is just a problem that we can kind of complete using algebra, where we have -7 over 12 minus 1/12 g of 1 equals -1. So if we add -1/12 g of 1 is equal to negative 1 plus 7/12. So if you think about what that would be, is that means negative 1/12 g of 1 equals negative 5/12. And if we multiply by negative 1/12, g of 1 is equal to just 5. And we finish it there. I know I went through those pretty fast. I'll do. You can pause and go back to the video and look at them again if you need help. Let me know if you have any questions.